For this group, folks, we have kind of a special guest today. This young lady's name is Miss Harney, Megan Harney.
Hi, everyone.
There she is there. And I met Megan recently at an event in Washington, D.C., and Megan works for a company called Midas Education. What they do is they work with database programs, and she does a lot of coding and programming to make databases talk to each other. Is everybody here familiar with what a database is?
Yes.
Okay. And it's difficult sometimes to get databases in big companies and big environments to talk to each other. So she does a lot of work with that. So what's really relevant to her work is what you are starting to do today, or you're going to do when we get done with this today, is you're going to be working in the computer science realm around coding and programming. And Ms. Harney here does a lot of that for the work that she does. And maybe, Ms. Harney, if you could just tell us for a few minutes, like, your background, how you kind of get interested in that kind of field, and then maybe we'll talk a little bit, maybe have the students ask you some questions about maybe some of the things you do day to day and what kinds of things, what kind of work you do. That'd be great.
Sure, that'd be great. So I didn't start programming until I was a senior in college. So you guys are really lucky because you guys are, 8, 9 years old, and I was 21 when I started programming, 20 maybe when I started programming. So you guys have got a 12-year jump on me. So that's kind of cool. I started figuring out that I wanted to write. I was teaching kids who were older than you. And I decided that I wanted to start being able to have them do some things on the computer, turn in their homework on the computer. And it wasn't just like I wanted them to send me an email. I wanted them to be able to actually do some activities where they'd answer questions. So I wanted to write activities like that. And I discovered that to do that, I needed to learn how to write computer code. So I took my first programming class when I was a senior in college. And I took 2 more classes that year. And then I went to work for Microsoft and taught myself a lot about how to program.
So talk to us a little bit about how, when you say taught yourself how to program, because these guys are doing some of that here today. What are some of the things what are some of the skills that came forth for you that you needed to apply to do that?
So in order to learn how to program, first of all, you've got to be pretty good at math. And you've got to be good at, besides math, you've got to be good at logic. So you've got to think about how do things work. So there are 2 key concepts in programming that I think you guys have to know. One is called a condition. Can anybody answer me? Do you know what a condition is?
Go ahead. We got one here. Go ahead. Speak right up.
A condition is, do you mean like the condition that somebody is in, or like another kind of condition?
I mean a different kind of condition, like when might I use an umbrella?
Well, you would use an umbrella like in the rain, or
in the rain, exactly, right. So if I walk outside and I'm deciding whether or not to use an umbrella, I might say, if it's raining, use an umbrella, and if it's not raining, don't use an umbrella. Does that make sense? Right? I'm making a decision. So one of the key concepts you want to think about in programming is having conditions. If one thing is true, do this. And if it's false, do this instead. Right? So, if it's late.
Here, we're gonna take a quick. That's a good one. Let's. There's a couple students with their hands up, so let's ask them if they can come up with a couple other conditions.
Great. Come up with a few more conditions for me.
All right. How about you?
If it is snowing outside one day, you would want to wear a coat.
Okay, that's a good one. That's a condition. All right. What's another one?
So the first big important concept for programming that you have to think of is a condition. And the second important concept you have to think about is called a loop. Okay, and what a loop means is that you repeat doing something a whole bunch of times. So when it snows, you have to shovel the driveway, right?
Yes.
And if you break shoveling the driveway down into little tiny steps, what you really do is you take the shovel and you dig it into the snow one time, you pick up some snow, and you throw it away, right? And then you look at the driveway and you say, is there still snow there? Yes. So I'm going to dig my shovel in. Okay, so then I've taken a shovel full of snow and I've thrown it away. And then I look at my driveway and I say, is there still snow there? And the answer is yes. So then I need to take my shovel and I need to pick up some more snow and throw it away again. And then I look at the driveway and I say, is there still snow? Yes, there is. And I keep doing that until all the snow is gone, until the driveway is shoveled. Does that make sense?
Yes.
Okay, so a loop is where you keep doing something over and over and over again until you're done. Can you guys think of other situations where you have to keep doing things, you have to keep doing something until it's done?
Yeah, we got a bunch of examples here. All right, why don't you tell us one?
You'd need to, like, if there's a whole bunch of, like, if you dump something on the floor, you have to pick a few things. You have to take a handful of the things, put it away in the bin. And
Yep. Cleaning up your mess on the floor, right? Yep, same deal. How about one down here?
If it's like fall or autumn and lots of leaves have fallen from the tree, you have to rake up the leaves, put them in the bag, and bring them to the dump or something and keep them.
That's good. That's another good loop. Yeah. How about in the back there?
well, I was gonna say, walking. You have to take one step, lift your foot, put it down, and lift your foot, put it down.
Walking's a good one. That's one we do all the time, right? Yeah.
So
All right, one more right here.
Like, if you're going skiing, you have to go up the tram or something that gets you up the mountain, ski down the mountain again, go up something that gets you up the mountain, and then ski down it again.
Yeah. That's a fun loop, though. That's not like snow shoveling, right?
Okay, so the two things you need to know are a condition and a loop. That's basically all of programming. All the logic of programming is in those two concepts, and then you just combine them in different ways. So imagine if you were asking a condition, if this happens, then I'm going to do this, and you put it in a loop. So you ask the question a whole bunch of times. So anyway, if you put those two ideas together, sometimes doing a loop and sometimes doing a condition, that's basically all there is to programming. And I think that's probably enough for me to explain. Do you guys have some questions?
Yes. How does programming actually program?
Sorry, how does programming what?
Actually program.
How does it actually program? Okay. So
Hold on.
I'm going to try to explain this and not be too complicated. But when you're writing what you write to program the computer, that's written in a language that you can understand as a human. So it's something, that uses words and numbers. And then what the computer does is it goes ahead and it translates it. Do you guys understand what translation is? You guys know there are different human languages, right? Like French, Spanish, that sort of thing. Well, the computer only communicates in numbers. So when it gets down to the level of what the computer disk can read, it has to be all numbers. So it goes from translating what you write in language into just zeros and ones. Have you guys heard of that before? Heard of that computer talk in zeros and ones?
Yes.
We got a mixed bag here, yeah.
Yeah, some of you have heard that. So it gets pretty complicated, and you can take whole classes on it. But there are ways to translate languages, just like you translate human languages, that translate what you write to the computer into zeros and ones. And does anybody know why the computer uses zeros and ones? No? Okay. Well, the computer runs on electricity. Oh, I see a couple hands up.
Well, I'm just taking a guess, but like zeros and ones is like negative, positive, and stuff like negative.
So the computer, it has the zeros and ones because electricity can either be on or off. That's the only choice, right? That's the only way it can communicate. So a zero, I think a zero represents on or off. And so one represents what? On. Right. So just by combining zeros and ones, by combining ons and offs, it tells the computer, hey, are you getting a little bit of electricity on right now, or is the electricity off? And depending on how many times it does that and how many times it gets a signal for on or off, tells the computer what to do.
Well, how can girls get more into it? Because seems like a lot of boys like it, and I really like programming and like computers.
You just do it.
Yeah, well, for a girl to get into it, you've got to just do it, right? You've got to not be intimidated, and you've got to try it. And as you try it and you program something and you see that it works, you're going to feel more confident about it. And don't ever let anybody tell you that you can't do it because you're a girl.
Okay.
So maybe share, like, so when you get into programming, like, for example, how many boys were in your class when you get into programming?
Oh gosh, I was one of just a very few girls.
Hold on. Keep going.
I was only a very few girls. There were not many girls in my classes.
Yeah,
Okay, how many boys and how many girls? Very few girls. Did you say?
Well, I was in a big class of maybe 200 or 300 people in college, so
Wait.
it was hard to count. But I bet it was. Oh, I bet there were maybe 20% girls.
And that's
So-
a high number. That's a very high number.
That's right. Yeah, at least 80% boys. Yeah, that's right.
Well, it was a lot more boys than girls.
Wait.
All the programmers that I've worked with professionally have been men. Have been boys.
Do you get
Yeah,
to?
we're-
Arduino last year, and I want to know how, like, I could do something better with an Arduino, and just and like, how do I think better? And
We actually really want to get to programming, so we might say thank you very much and say goodbye.
Nice to see you guys.
This has been great. This has been great. Thank you both very much.
Sure. Bye bye.
I'll be in touch in a little bit. All right.
Okay. Bye bye.
All right. Thanks all.